Thanks for the chance to make a pitch for the Cholame Parkville transition along the San Andreas Fault as an first order contrast in seismic behavior. So it's an earthquake gate for sure. This diagram on the right shows the classic first order segmentation of the San Andreas Fault system as presented by Clarence Allen in 1968. And you can see here that the Parkville and Cholame transition is right in the middle of this system, where we go from the 1857 break, which is thought to be locked and only productive of great earthquakes, with then the transition to the northwest into the Central California active area, which is dominated by creep and moderate events. And that transition is really well manifest by Parkville and Cholame. So the gate is defined by changing material properties and slip behavior. There's rich phenomena for our collaboratory to investigate, including the localized plate boundary deformation. This is the oldest part of the San Andreas with 300 plus kilometers of offset right through this zone. It has spectacular tectonic geomorphology and earthquake geology. There's a strong record and pattern of variation and coupling along the fault in space and time. It's a zone where there's been classically described foreshocks, main shocks and aftershocks of great California earthquakes, and there's rich tremor and microseismicity deep in the system. There are opportunities to leverage substantial prior and ongoing research, major infrastructure investments, and connections to Southern California. We're literally stepping to the northwest from Southern California towards the Bay Area and beyond. Many questions remain. What are the geometric and mechanical relationships among strike, slip, and reverse faults? The controls on fault strength and segmentation, evolution and fault behavior over the seismic cycle and various senses of that term, system-wide interactions, how does this whole system work, and prehistoric rupture behavior. We still don't really know what happened in the past. And I want to acknowledge Cliff Thurber and his 2011 proposal for Parkville as a special fault study area. In 1857, there was a foreshock at dawn and another at sunrise before the great 1857 earthquake that occurred at about 8:30 in the morning, and it affected all of Southern California. What's striking is not only the nature of that iconic event, but also the fact that those foreshocks look a lot like historic Parkville earthquakes. This is an important place to continue to study. You can see on the upper right an aftershock from 1857. This is by Meltzer and Wald, sort of southern part of the 1857 rupture zone. And then even a forecast aftershock nucleation following a Parkville earthquake that includes activation of a lot of the San Andreas system. That's from Field et al. 2017. So in spite of all of this, what happened in 1857? Anyway, we don't really know. Work by Julian Lozo, some dynamic rupture modeling is suggesting that it's pretty hard to get these 1857 type events to go around the Big Bend, and also questions, does 1857 earthquake really start in the northwestern rupture southeast or not? And so the interactions between the creeping section, Parkville, Cholame, Carrizo are more complicated than classically argued. And so the variation in coupling along the fault defines the gate. And this is one example of many that shows the variation in slip rate along the fault surface as inferred from geodesy, and also showing some of the really beautiful seismicity of the area. And you see the data, just one example of recently published data. This is right lateral creep from topographic differencing, and you can see this really beautiful increase in creep rate along the San Andreas over a decadal time scale as we come out of Parkville. And that's consistent with then what is seen in Kai Johnson's model here, where he's showing this kind of finger of low slip rate that sort of reaches in from Cholame into Parkville, and then you see the creeping section to the left. And so this Parkville's just right in this transition. And then finally, the chance to leverage major investments in geophysical instrumentation, both in terms of observations, the O in SAFOD as observatory, and it is maintained as a really spectacular facility for observing many features in the near field of these earthquakes, but there are many other instruments that are in the region that could be activated. So I'll stop there. I have a number of other slides that can develop some of these concepts if there's interest.